Hello, geometry students. We are doing day 3 of parallelograms. And today's the first day where we really just focus on this particular type of quadrilateral versus a bunch of different polygons, which is what we've talked about the last couple days, and the angle sums and so on. So I'm hoping as we go through this first page, you're like, I remember a bunch of this stuff from like middle school details, right? So the first part, when it says, how many degrees are in a quadrilateral? Well, we know it's n minus 2 and then times 180. So since quadrilateral would be 4, it's just 180 times 4 minus 2, or 2. And it should come out 360. Again, probably something you knew already. And you can tell, like, you're dividing it into 2 different triangles if you actually break it up with that diagonal. All right, as for specific parallelogram properties, let's do it. So first things first, the definition of a parallelogram is that the opposite sides are parallel. But I'm going to say that both pairs, of opposite sides are parallel. And I'm going to use the symbol for parallel there. You can write it out if you prefer, but it's a lot easier just to use the symbol. And then we know in the diagram, arrows is how we show that things are parallel. So DC and AB, and then AD and BC there. All right. Other properties that you might be able to remember. Opposite sides are equal, or you can say congruent, either or. So I'm going to mark it with the little dashes this time to say that both pairs of opposite sides are congruent. Other things we should know. Both pairs of opposite angles are congruent. And think about how to show that. We can mark with just maybe a single swipe angles D and B, those would be opposite angles, and then A and C. So literally the ones that are across from each other like that and across from each other like that. All right. The next one sounds a little clunky, but should make sense when you look at it visually. And that's that consecutive angles are supplementary. All right, so consecutive means in a row. So if I have like angle D and then angle C over here, it's not that they're equal to each other, but supplementary we know means that they add to 180. So these two together, like D and C, we could say add up to equal 180. And C and B would be another example. These two add together to equal 180. All right. Maybe I should put equal and not plus, but hopefully you get the deal there. All right, so any two that would go in a row, so B and A, and then A and D would be fine as well. As for the last ones, we've got the diagonals drawn in, and that's because the diagonals bisect each other. Bisect, we know that right off of our proofs. So when we think bisector implies 2 congruent segments. So that means that DE is congruent to EB and AE is congruent to EC. And if you're looking at this, you can probably see a bunch of little triangles, that you can prove congruent right here. So those are good details to talk about, right? Now the diagonals themselves, though, are not congruent. So just as a side note, the diagonals are not necessarily congruent. So the more you kind of tilt the parallelogram, one diagonal gets shorter, the other one stretches and gets longer. All right. So that means that the little parts are the same, but the sums of the parts would not be equal to one another. So everything we just said can actually be put into proof form and eventually will. We're not done with proofs yet, but we take a little pause until we get there. All right, on to the next page. We have some examples using all those different properties. You might want your calculator next to you because we are back in those calculations here. So it says if angle A is 60 degrees, so go ahead and mark that here. Find all the other angles of the parallelogram. So this first one is meant to be quick and easy, that the opposite angles are equal. So this guy should be 60. And then consecutive angles should add up to 180. So if we go 180 minus 60, that's going to leave us with 120 here. And then its opposite angle should also equal 120. You're going to see that property show up a bunch. All right, in parallelogram ABCD, if angle B exceeds angle A by 50, find the degree measure of angle B. All right, a couple things. If they say parallelogram ABCD, when you draw the parallelogram, you can draw it however you like, but when you label it, those letters need to go in order on the diagram itself. So I would need to go A, B, and then keep going C, D. So you don't want to pick up and go A, B, and then come back to the bottom. So I should be able to trace my way around in that order. And that's important because it will change the relationship if you have the angles in the wrong spots. So angle B exceeds angle A by 50 degrees. So from that, I would say, let's let angle A be X. And then angle B, if it exceeds it by 50, X plus 50 right there. Find the degree measure of angle B. Well, because these are consecutive angles, they have to add up to equal 180 degrees. So we can set our equation up and then solve from here. So we get 2x plus 50. We can absolutely subtract that 50 over. So that 2x equals 130. And then divide it by 2. And you can always grab your calculator to double check. It should be 65 for the value of x. But then this one specifically says what's the measure of angle B. So angle A would be 65. Angle B is now going to be 65 plus 50. So feel free, you can grab your calculator if need be. So 65 and then add 50 to that. We should be up at 115. So we end up with an obtuse angle here. All right. Down at the bottom, you got some other properties because we have the diagonals drawn in. So you got to think, we said diagonals bisect one another. So when it asks you to find JG, this particular part of the diagonal, and then FH, the whole diagonal here, what we want to remember is that since the diagonals bisect each other, we have all these little pieces that are congruent. So this piece is congruent to this one. This piece here congruent to that one. So when it's asking us for the first part to find JG, we can set up, maybe I'll come over here, set up an equation by setting the pieces equal to each other. All right. So 3W equals W plus 8. When we move some things around, we can solve for W. W comes out to be 4 here. And then to find JG, make sure to finish that piece of the problem. J to G is just this part of it. So then it would be 4 plus 8 or 12. So that first part comes out 12. When you go to do part B has a completely different diagonal and different variables in it. So you can kind of tell they're not necessarily related to one another. So even though I'm looking for the whole thing, I would still want to start it the same way to say, hey, this part is going to be equal to that part. Or as always, you know, I always love to have like my random colors and things floating around here. You can always kind of circle one in one color, one in another, if that's helpful, especially when you look back at it. Sometimes it's a really fast visual way to see what was going on. So we can say 4z minus 9 equals 2z and then take it from there. You can either subtract 4z over, or you can move 9 and then subtract the 2z. Either way, because you end up with double negative when we do it this way, but that's all right because double negative means it'll cancel, and we get z equals 4.5. So now to find the entire length, you can plug back into both pieces and add together, or you can plug into one piece. So like JH is 2 times z, which would give us 9. And if we're doing it correctly, the two parts should be equal. So FH is just going to be 2 times that, or 18. Now, something to keep in mind. When you look at this, Are they always going to be drawn to scale? No, not necessarily. So the first one was saying that just this part of it was 12, and then that would make the whole thing 24 and this 18. It seems at least reasonable, but please don't let that throw you off. If you're like, oh, but it looks bigger, not necessarily going to be drawn to scale here. All right. And that can definitely happen, not intentionally to confuse you or anything, but just don't be thrown off if it does happen. All right. This next one, let's focus on just the angles here. So it says, given parallelogram ABCD, find all of the indicated angles. All right. Because we have a whole bunch of parallel lines, think about what parallel lines can get us. From our proofs, parallel lines would get us congruent alternate interior angles. They can give us same side interior angles being supplementary. So there's a whole bunch of stuff that we can come up with here. But since I started by saying alternate interiors, let's start with that. All right. So the fact that we have the top line here and the bottom line parallel, if I trace it out, you can see that Z shape popping right out there. That means my little crooks of my angles should be equal. So since this was 16, so is that guy. All right. And then we could actually do it the opposite direction as well. And so if I make sort of like a backwards Z here, see if I have some other colors floating around my desk here. If I kind of go a little backwards Z, there we go, 37. And then that makes this 37. So the goal should be fill in every angle you can possibly find here. All right. As for that 42 off to the side there, that is using this set of parallel lines. If I were to connect this way, now I can kind of see that N, almost an upside down N shape, but that 42 will match this 42 over here. All right. And then we have one last little kind of missing angle next to the angle of 37. So some things that you can do. You can use the fact that you have little triangles going on and every triangle is 180 degrees. Or I could look at this entire angle here. So 42 and 16 total would give us what, 58. And then these two plus this top one have to be supplementary because those are consecutive angles. So if I add 58, and right now I can add 37 to it. I'll grab my calculator just to double check. And right now it adds up to 95. So this remaining angle has to get us all the way to 180. So if I go 180 minus 95, that's going to leave us with 85. So that's one way to get this angle. And then its alternate interior would be over here, would be 85. As for those middle angles, I can use the fact that we have little triangles here. So like my triangle at the bottom, I'll kind of outline it so you can see what I'm talking about. So triangle DEC, I have 16, 37, and then I can get that last angle by adding and subtracting from 180. So if I add 16 and 37, 16 plus 37 will give me 53. And then if I subtract that from 180, that would leave me with 127. So this angle would be 127. All right, here comes more vocab. Its vertical angle would be 127. And then the angle next to it, that's actually this 53 right here. Okay, so now what angles did they even ask us for? Well, ACD, trace carefully. ACD, that's this guy. That was 37. DBC, so DBC, that's this top corner. That was 42. Angle AED, AED, that's this one on the left here. That's 53. And then measure of angle BCE, BCE, that's this guy right here. That's 85. So basically every single angle we solved for, they asked, right? But just keep in mind, if you're not sure how to find the one they're asking you for, anything. Can you find one alternate interior? Can you find a vertical angle? Can you find a triangle sum that's 180? And just kind of let the numbers keep on falling into place. All right. On these next ones, we're going to save some of these as a little post-video question here. So for number 5, that one I want you to try. And I'm going to ask you, what the value of X is in the post video question right there. All right, so number 5 on page 13, that is your post video question. If you need to pause and try it right now, go ahead. I'm going to keep moving right past it, but if you want to do it at the end, you can do it then. Otherwise, go ahead and mark number 6 as a question that we're going to recap in class. So we're going to talk about both of those, but post video is number 5, 6 we'll save for class. Number 7, let's take a look at it. It says the degree measure of two opposite angles of a parallelogram are represented by 3x plus 40, x plus 70. You don't even have to necessarily draw the picture, but you can. Don't worry about how pretty it is. Just x plus 70 for one, and then the opposite angle, 3x plus 40. All right. All you need to know is that opposite angles are equal or congruent, whichever way you'd like to say it. So 3x plus 40 equals x plus 70, and then solve from there. So I'm going to multi-step this one. I'm going to subtract x and subtract 40 at the same time, which gives me 2x equals 30. Divide by 2, we get x equals 15. Now, if it just said solve for x, you'd be done. It says find the degree measure of one of the angles. Well, they're both the same thing. So if I plug in, let's say to the one I have up here, then 15 plus 70, that would give me 85. Right. And here's a perfect example of I drew the picture myself and I didn't know if the angles were going to be acute or obtuse. So don't worry too much about, what your diagram looks like in those cases for sure. All right, we have one last page with a couple more practice questions to talk about. So on to page 14 here. For this one, it says you've got parallelogram ABCD. They're giving you BC, AD, AB, and so on. So let's figure out what the heck that is in the picture. So again, remind yourself. Letters have to go in order. So A, B, C, D. BC is 9y plus 10. AD, 6y plus 40. And then AB, 1/2 y plus 50. And then find the measures basically of all the sides here. Okay. What you know at this point, opposite sides are congruent because it's a parallelogram. If we don't know this side over here, then I don't want to work with this one just yet. But I know that BC and AD have to be equal. So I'm going to ignore this for a moment, and I'm just going to use these guys and set them equal to each other. So if I do 9y plus 10, set it equal to 6y plus 40, I can use this equation to solve for y. So again, we can kind of multitask here, shimmy some things around. So we get 3y on the left. I'm going to get 30 on the right. And then when I divide, I get y equals 10. That's what I need to now solve for all these other sides. So BC should be 9 times 10 plus 10. That's going to come out as 100. And now what's the unit of measure? I don't know. So 100 units is fine. All right. AD should be the same thing. If you want to check your work as you're doing it, then yeah, plug into both and you can double check. So there's 60 plus 40. That checks out right there. All right. And then AB, now you can plug into that 1/2 of 10 plus 50. Well, that'd be 5. And then plus 50, that's going to give us 55 right there. And then CD has to be the same thing. And there we go. All right. As for what's left, I'm going to skip number 9, but I want to look at one of the multiple choice questions here. Right? So number 10, it says in parallelogram ABCD, which is always true. So again, give yourself a little visual. So A, B, C, D. All right. AB equal to AD. So this equal to this. Not necessarily. All right. Does not have to be true. AB equal to DC. All right. Yeah, those are the ones across from each other. So I'm thinking that's our answer, but let's double check. AB being parallel to AD. No, if they share a point, they can't be parallel to one another. All right. And then angle A being congruent to angle B. Well, that could be true, but it does not have to always be true. So choice B, that should be our answer there. All right. Number 11, we'll talk about that guy in class tomorrow. Thanks so much for watching, guys. Go answer that post video question right now. See you later.